Alright, so we're going to look at graphing the cosecant of x. So what we want to remember about cosecant is that it is the reciprocal of sine. So cosecant of x is equal to 1 over sine x. That's what it means to be a reciprocal.
You're not sure. You're not sure.
So sorry. Thank you. And so when we want to graph cosecant of x, we're going to be using sine x as our base function to compare it to. So if we go back to the basics of the unit circle, alright, we're going around the unit circle, 0, pi over 2, pi, 3 pi over 2, back around to 2 pi. We remember that all of our ordered pairs around the circle are given as x, y, but those values are cosine, sine. So y is our sine value. And that all has to come from right triangle trigonometry, right? Because all around the circle, this unit circle, we have these right triangles. Right, we've got all these right triangles, and so this sine value comes from the fact of, here's our theta. Sine is opposite over hypotenuse, but the hypotenuse is 1 because it's a unit circle, so that's how we're getting this relationship. So, if we go in and make a table of values, and we're going to do x, and we're going to look at sine x, and then we're going to look at cosecant of x. So at 0, our y value is 0. So that means our cosecant is 1 over 0, because it's the reciprocal. So that means undefined. And so as soon as you see that a function is undefined at a given x value, asymptote, 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 right? That's the connection that needs to go in your brain. If the value for 0 is undefined, there will be an asymptote at x equals 0, right? So then at pi over 2, our sine of pi over 2 is 1. So our cosecant is 1 over 1, which is 1. So notice at pi over 2, your sine and your cosecant have the same value. Right? Then at pi, our sine value is 0. So our cosecant is 1 over 0, which is undefined. So we will have another asymptote at x equals pi. Then at 3 pi over 2, our sine is negative 1, right? Because we're here on the unit circle. Y value is negative 1. So our cosecant is 1 over negative 1, which is negative 1. So again, notice here that our sine and our cosecant have identical values. And then at 2 pi, our sine is 0, our cosecant is 1 over 0, which is undefined. Alright, so then we're going to come make that graph. And so the first thing that I'm going to do is I'm going to come in here and graph sine of x. So sine of x goes through 0, 0, pi over 2 we're at 1, at pi we're at 0, at pi over 2 we're at negative 1, and at 2 pi we're back at 0. Sine of x makes a hill, then a valley. And so now, in a different color pen, I'm going to come graph cosecant of x. So my cosecant of x is undefined at these values. So notice, wherever sine is 0, cosecant of x is undefined. So here on my graph, everywhere that sine is 0, that's where I have an asymptote. So at x equals 0, there's an asymptote. You want to make sure you can see your asymptote, right? So if you put it exactly on the y-axis, nobody will know it's there. Got to kind of put it to the side. Asymptote at x equals pi, and asymptote at x equals 2 pi. Alright, so then keep in mind here, right, as if we look here at our first quadrant of our unit circle, right, and we think about our sine values, so our sine values are always less than 1. So our cosecant, if you take 1 and you divide it by a fraction, it's going to come out bigger. So our cosecant numbers have to all be greater than 1, or equal to 1. I should say greater or equal. So right here at pi over 2, cosecant is the same value as sine. They share that point. But all of our cosecant values are going to be greater or equal to 1. So cosecant looks somewhat like a parabola, right? It's going to share this point at 1, and then it's going to come up towards this asymptote and up towards the other asymptote. And then the same thing's going to happen down here. It shares the point 3 pi over 2 negative 1, and then it's going to go down towards this asymptote and down towards this asymptote. Alright, so now let's look at all of our critical attributes. Amplitude, that's no amplitude, not applicable. We don't discuss amplitude when we're looking at cosecant. Minimum, negative infinity. Maximum, infinity. We're not going to talk about where the min and max occur because you can't actually land on negative infinity or infinity. This function begins at 0, ends at 2 pi, so the period length is 2 pi, like sine, right? That would make sense. If the period for sine is 2 pi and cosecant is the reciprocal, it's going to also have a period of 2 pi. X-intercepts, there are none here. Right? Look at your graph. The blue graph is never touching the x-axis. But now our domain. Like tangent and cotangent, the domain here gets a little tricky because anytime you have an asymptote, you've got to restrict your domain. So our domain is going to be x, such that x is an element of the real numbers, except x cannot be certain things. We'll look at where your asymptotes are. 0, pi, 2 pi, right? All the multiples of pi. So x cannot equal pi times n. Now, what if someone were to write 0 plus pi over n? Because they're like, Ms. Collier, I thought you always started with the first one and then you added. What's 0 plus pi over n? It's still pi over n, right?
Yeah.
So if you wrote 0 plus pi over n, would that still be correct? Yes.
Yes.
Okay. Alright, now the range is what's going to look different than any of the other functions that we've done. Because notice, we've got this piece in here. You see there's no cosecant values in this middle part. So that means our range is going to have a union. Right? We're going to have part of the range union with the other part of the range. Remember, when we do our range, we always start at the lowest. So it's starting at negative infinity. And then it goes up as high as negative 1. It equals negative 1, so there would be a bracket around negative 1. And then we pick up with a value of 1. So a bracket at 1, because we're on that value. And we go up to infinity. Alright, anybody have a question? Alright, I'm not seeing any questions, so we will move on. So let's say we were going to graph this transformation. Y equals 2 cosecant of x minus pi plus 1. So remember, in your transformations, this plus 1 is going to come last, right? And what is it going to cause? It's going to cause a vertical shift up 1. So what we want to do here is we want to graph the function y equals 2 times the sine of x minus pi. And then from here, we're just going to go, just take this graph and push it up 1, and then we can draw the cosecant from that. Alright, so let's take a look at it together. So this x minus pi, right, this is going to cause a horizontal shift. And this 2 is going to cause a vertical stretch. Right, it's going to change our amplitude. But everything else is going to stay the same. We have a 1 in front of the x, so it's not changing the period or anything. So I'm going to come through and I'm going to mark my graph pi over 2, pi, 3 pi over 2, 2 pi, but then I'm going to continue 5 pi over 2, and then 3 pi. Now, why did I go out there and not just stop at 2 pi? Because this horizontal shift is going to the right. So normally my sign would start here at 0, 0. So I'm just going to shift it to the right. So now at pi, it's going to be 0. And now I don't even need to build my table of values, right? Because I know what sine does. Here's 1. Here's 2. Sine would be at 1, 0, -1, 0. But now I've got an amplitude of 2. So instead it's going to be at 1, 2, 0, -2, 0. Hill and valley. So that's this graph. But now I'm going to take this graph and I'm going to shift it up 1. So if I shift this up 1, I'm going to be at 3. Now pay attention here. If this goes up 1, there's a tendency to just follow the hill and valley and go down. But no, you're raising this whole graph up 1. So this is going to go up to -1. And that's all we really need to mark. Because remember, we're not really graphing sine. We're graphing sine to help us do cosecant. So what do I know about my cosecant? I know that wherever sine is 0, my cosecant has an asymptote. So there's one at pi. There's an asymptote at 2 pi. And there's an asymptote at 3 pi. And then I know this maximum value for sine. I know that cosecant shares that point, and then cosecant goes this way, towards the asymptotes. And then I know that over here, cosecant shares this point and goes down towards those asymptotes. So now I've accomplished making my graph. So amplitude doesn't apply, min -infinity, max +infinity. This time the period begins at pi and ends at 3 pi, but the period length is still 2 pi long. X-intercepts, there are none. Now, I don't want you to think that there's always none, right? Instead of a +1, what if this had been +2? Do you see we would then go up there and get an x-intercept? But in this case, there are none. Alright, so the domain and the range are the ones that become a little trickier. We know our domain is restricted because we have asymptotes, but we're going to start x such that x is an element of the real numbers, but x cannot equal some stuff. Well, our first asymptote is at pi, and then it's occurring every pi. So I could write pi plus pi n, but I really don't need to, right? Because it's just pi n. Right, so just a little bit of algebra here, right? Pi plus pi n would be pi times 1 plus n. But remember, n is just an integer. So 1 plus n is just the next integer. So it doesn't matter. Alright, so then our range. Our range is going to go from -infinity and it's going to go up to -1. But then it's going to be union with 3 to infinity. Alright, tell me how you are with that in the chat. If you're okay, say okay. Give me a thumbs up. I'm good. I'm lost and confused. I don't understand asymptotes. Where are we at? Let me scroll through. Good, good, good. All good. Alright. Alright, so when you're writing the range, you do want to go from least to greatest. That's our agreed upon way to write a range, is always least to greatest. So we would put the one that has negative infinity first. Because as you're going range, you're going like this. Alright, so that's cosecant. So now we're going to switch over to secant. So if we have the function y equals secant of x, we want to recall that secant is the reciprocal of cosine. So what that means is that secant of x is equal to 1 over cosine x. That's what it means to be a reciprocal. And so again, we're going to tie everything back to our unit circle. Remember, you're at 0, pi over 2, pi, 3 pi over 2, back up to 2 pi. And if we're looking at a cosine, we're looking at the x values there, right? So we're going to make a table for x, cosine x, and then secant x. So at 0, cosine is 1. So cosecant is 1 over 1, which is 1. So cosecant and secant have the same value when x is 0. At pi over 2, up here, the cosecant is 0. So secant is 1 over 0, which is undefined. And so you're thinking, oh, undefined asymptote. I know my graph has an asymptote right away. Alright, at pi, the cosine value is -1. So it's 1 over -1, which is -1. So again, cosine and secant have the same value. 3 pi over 2, cosine is 0. So secant is 1 over 0. Oh, undefined, another asymptote. And then at 2 pi, cosecant is 1. Secant is 1 over 1, which is 1. Alright, so now let's graph. Like we did before, we're going to graph cosine first. So cosine starts at 0, 1, goes to 0. At pi, it goes down to -1, 0, back up to 1. Remember, it's curving like this, like this, like this. So my purple, that's my cosine. So now I'm going to come graph secant. And so the first thing I know is that whenever the cosine value is 0, the secant is undefined. So here cosine is 0. So secant is undefined. So there's an asymptote. Cosine is 0. Secant is undefined. There's an asymptote. Now, my cosine values are all in between -1 and 1. My secant values are all going to be 1 greater, -1 less than. So remember here at pi, my secant is -1. So cosine and secant share that point. And then the secant is going to go like this. Sort of looks like a parabola. It's not actually, but it appears like that. Parabolas are for quadratics. Alright, then here at 0, my secant shares this point of 1, and it goes this way and approaches that asymptote. And then here at 2 pi, it shares the point of 1, and then it approaches the asymptote this way. Now, think about this. If I took this period, because this is only one period, right? And then I came and copied it over here, this part right here is going to be over here, right? So if you did more than one period, you would have these full U-shape and upside down U's, right? But it looks split like that because we're only doing one period. Alright, so let's look at our attributes. Amplitude, not applicable here, no amplitude. Minimum, -infinity. Max, +infinity. We're going from 0 to 2 pi, so the period is 2 pi, because the period for cosine is 2 pi. X-intercepts, there's none. Right, so all that's pretty boring. But the domain and range are the ones here that get interesting. So our domain, we've got asymptotes, so your domain will be restricted. X, such that X is an element of the real numbers, but X cannot equal. So let's look at where our asymptotes are. We've got an asymptote at pi over 2. And then what's the distance until we get to our next asymptote? How far away are our two asymptotes?
Pi.
Pi, right? And if you're like, Ms. Collier, how did you know that? How are other people seeing that so quickly? Well, this is pi over 2, right? Each interval. So it's pi over 2 and another pi over 2. Half a pi and half a pi makes a whole pi. The other thing is you do subtraction. 3 pi over 2 minus pi over 2 gives you 2 pi over 2, which is just pi. So plus pi n. Then our range, again, we've got our secant function is kind of split into these different branches. So our range is going to have a union in it. And we're going to go from least to greatest. So the lowest is your minimum, which is -infinity. And then it goes up until it reaches -1, bracket. And then it picks back up again at 1 and goes up to a maximum of infinity.